The neutron moved slowly, not slowly in the ordinary sense, but slowly in the language of quantum mechanics, where motion is measured not only by speed, but by wavelength. As its energy fell, its wavelength grew. It stretched outward, longer than the nucleus it was approaching, longer than the distance across the forces hidden inside matter. To the neutron, the nucleus did not appear detailed. It did not look like a crowded core of protons and neutrons. It did not reveal sharp edges, or layered structure, or hidden complexity. It appeared smooth, almost featureless, a quiet presence in space. In the quantum world, what you see depends on how gently you look. At high energy, particles probe deeply, they collide. They break things apart. They expose structure. But at low energy, the rules change, details fade, and the neutron, moving slowly, could no longer resolve what lay inside the nucleus. It could only sense that something was there. As the neutron drifted closer, there was no sudden event, no sharp collision, no dramatic impact. Instead, its wave began to bend. The neutron was no longer a point, but a spreading wave extending across space. And as that wave encountered the nuclear boundary, it wrapped gently around it, flowing, curving, dividing itself into many directions at once. This was diffraction, not violence, but redirection, not chaos, but symmetry. In this regime, the interaction is known as S-wave scattering, the quietest kind of encounter nature allows. Here, motion is so slow that only the simplest pattern survives. No angular structure, no sharp features, only a smooth, spherical response. And remarkably, everything that happens here is governed by a single number, one length scale, the scattering length. That number carries a hidden story. It quietly encodes the entire influence of the nuclear force. Whether the nucleus could almost bind the neutron, or whether it would simply let it pass. Whether attraction was strong but fleeting, or weak and indifferent. The neutron does not know the details. It does not see the force directly, but the scattering length remembers. Inside that one number is the echo of the strong force, compressed, simplified, reduced. A force that at high energies is violent and complex. Here speaks softly. As the neutron wave continued to spread, it scattered evenly in all directions. No preferred angle, no signature of internal structure. To an outside observer, the interaction looked deceptively simple, as if the neutron had encountered a perfectly round, invisible sphere, defined not by matter, but by influence, defined not by shape, but by effect. In this low-energy world, even the strongest interactions lose their sharp edges. They stop shouting. They speak softly, and a single parameter is enough to tell the whole story, not because the universe has become simple, but because, for a moment, we have learned how to listen.